Hi there, and welcome to today's demo in British Columbia Institute of Technology Teacher Education 4044. Today we're going to take a look at how to design a parametric laser cut truss in Fusion 360. For students in my class, this is an optional extra. You've designed a laser cut truss in AutoCAD already. Probably did your design work on paper and then drew it in AutoCAD. But today I want to take a look at what some of the benefits of using the parametric functions in Fusion 360 are so that you can get different model iterations calculated very quickly. Now, as I go through this video, I'm going to make some references to the other videos on this playlist, and I'm going to be using my fancy pants 3D mouse right in here. So in previous videos, I've shown you how to come along and take a look at a truss like this, and we've been able to do structural buckling and static stress analysis on here. So we've been able to do finite element analysis to look at how our structure is going to behave under load. And sometimes you want to go through and you want to adjust parts of your truss so that you can try different iterations to see, am I better to make the truss wider, taller, or various things. Now, although it's easy to change the width, and we did that in the previous video, I wanted to show you how you can use the parametric features of Fusion 360 to make it so that you can come along and change some of these properties really, really quickly right in Fusion 360. So what Parametric's going to let you do is if I come back to my design right in here, and here's my truss right in here, and you can see that I've got a certain amount of height right in here. I'm going to come back to my initial sketch, and in the previous video that I showed you, I just brought this in from AutoCAD. So I had a fixed sketch, but making this parametric, I can come in here, and this is what makes parametric modeling in programs like Fusion 360, SolidWorks, Autodesk Inventor just so cool, is that rather than having to redo the drawing and then redimension it, you just come in and change the dimension. And I want to make that tower 150 millimeters high. And if you've designed the structure properly, everything adapts and adjusts. And if I want to change the spacing off one of my nodes right here, uh, I can change that. And if I say, oh, look at, I've probably used a little bit too much material or maybe not quite enough in here. Oh, that's 3.5 and 3.5, that's 7 millimeters thick. That's as thick as I can go. But maybe some of these members in here could come down a little bit thinner. All I've got to do is come in here, click on that 2, at -2, turn it to -1, change that to -1. Oh, sorry, that was a positive, change that to 1. And now you can see that I can bring all of these down. And rather than having to redraw my structure, I just redimension it. And when I finish that sketch, now those changes have been applied right there, and everything in that sketch has now been adapted all the way through the model. My model is taller now, it's got some thinner members, it's got a longer base sticking out the back right here. And so this structure is now all ready to go back and be resimulated with the new dimensions. Now, obviously, we're looking at that and we're saying, well, okay, that one's looking a little bit tall. I might have to put a new node in there. That requires a little more significant editing. But if you're just looking at dimensional changes, parametric modeling makes that super easy for you. So I want to show you how to set that up because it's a great tool when you're designing something and you're not exactly sure what size it's going to be. Okay, now before I jump into doing too much of that, I'm just going to shrink myself down here a little bit and move myself off to the bottom corner here so I'm kind of out of your way while we're watching what's going on with Fusion 360. But I also want to bring in my other camera right here where I've got some note sheets. Now, before I begin any kind of parametric modeling, pardon me as I jiggle the screens around right here, I like to come in here and I like to do a little bit of calculation first. I try not to do my design work in Fusion 360. just like I wouldn't do my design work in AutoCAD, I like to do my design work on paper. My brain still works that way. And I know when I was younger, I would sit down and just start hacking away at it. And I guess maybe experience has brought me back this way. So if you prefer, if you're sitting there saying, oh no, I do all my design work right away and I create my sketches and that's what parametric modeling is all about, then go right ahead. You can do it that way. But I like to think a few things through first and do some calculations. So one of the interesting things about the challenge that my students are doing right now is that their truss has to be cut entirely out of a 600 by 400 millimeter piece of material because that fits on our laser cutter really nicely. Actually, pardon me, I think it's 450. Uh, 24 by 18 is the imperial size. So yeah, 600 by 450. And anyways, I've done the calculations on here and figured this out so that we've got a scoring formula. So your score, which you're trying to maximize, is your length squared divided by your mass. And a little bit of algebra lets you go through and predict what sort of masses you're going to need in order to achieve a score. And in class already and in the simulations that I've demonstrated, scoring somewhere in the 2000 range is pretty trivial. So I think I want to score between 4,000 and 5,000 points. Now there's many possible ways that you can arrange your truss to be cut out of your piece of hardboard. However, you've got to cut both sections out of the same piece of hardboard, and each section has to be contiguous, okay? So you can't cut out one part there and then cut out another part over here and then glue them back together. That's actually a really good idea, and I wish I could say, yeah, go ahead and do that, but I know what that would do to the amount of time involved in laser cutting and assembly, and I do try to put some of these rules in place just to keep it so that this is achievable during the class time that we've got. Okay, so let's take a look right here. We've got two ways we could arrange it. You could put your truss coming along the bottom right in here, kind of, like so, or you could put a truss and cut it out diagonally right here, because that way you'd be able to cut out the mirrored image of that truss on the other half. Okay, I guess it would technically be the rotated image, but anyway, so you can cut out one half from that side, one half from that side, or you can cut out one part down here and then one part mirrored and up and over there. And if you think about the requirements for our design requires you to have a 30 millimeter diameter node at the back end. That's going to be your fixed node. And so that means that the first 15 millimeters here is one half of that node diameter. So you don't get to use that first 15 millimeters. And then you've got to have another node doing the support, and your nodes have to be a minimum of 70 millimeters apart. So that second support node is going to be 70 millimeters apart right in there. So your long arm that's doing all the support out here is at a maximum, when you make it horizontal, going to be 510 millimeters, because you lose 15 millimeters here, 70 millimeters here, and 5 millimeters right over here out of your total of 600. However, if you turn it diagonally, of course, things get a little bit longer at the cost of running out of space right up here to make it taller. And as you know, when you make a truss shorter, or any structure shorter, that creates more horizontal force relative to your vertical force, and that's going to create a lot of problems for you in that design. However, if you go this way, I believe I calculated, I did a tangent radius circle right here to figure out how close I could tuck this into the end, and I got that up to basically 695 millimeters from the center of this node to the center of that node. And so I subtract my 70 for the support side. That leaves me with a total of 625 millimeters. I think with a little bit of tweaking, you might be able to get that a little bit longer, but I'm going to say 625 is about as long as you can get going in the horizontal dimensions. So now I can make a couple of predictions, and if I want to score between 4,000 points and 5,000 points, if I create a horizontal or a diagonal truss like this, then I need to get between 78 grams and 100 grams. And if I create it across the bottom, a 510 millimeter long unsupported arm, cantilevered arm, then I need to get down between 52 grams and 65 grams. And I'm not sure which one's going to be the easiest one to get to just yet, so maybe taking a look at parametric modeling is going to be something that will help me out a little bit. Now again, I like to start out with a sketch before I start working. So before I started creating this design, I had this little sketch in mind, and I came along and I did a little bit of math, and I said, well, how far apart do I want these to be? Because if I knew that going in, then I'd have something to start basing my design on. And the design ended up with a couple of weird things that I'd probably go back and change. Like right now, this comes down right here, and then it angles up over here. I think ideally I probably want that coming down and finishing up right there. So maybe instead of having 1, 2, 3, 4, 5, 6, 7 nodes along the bottom, maybe I want to put 8 nodes along the bottom. And you know what? I think I'm going to try that in this truss. So if I want 8 nodes along the bottom, and I'm going to spread that across. What did I say that lever arm is going to be right there? If I want 8 nodes across 510 millimeters, then I am just going to come along and say 510 divided by 8. I want those nodes. Oh, I can't do that. 63 millimeters is too short. The rule says nodes can only be 70 millimeters. So maybe I want to have 6 going across there, just so that I get slightly different arrangement. Let's take a look. What was that? 510. So I'm going to make this one with my nodes along the bottom 85 millimeters apart. So I'm going to try that. 85 millimeters times 6 nodes equals 510 millimeters from there to there, which is pretty close to my maximum. And that'll give me a little bit of a different design. And then we'll take a look along the top. And this one I've got drawn as it's not a, is that a Warren truss? I'm trying to remember all the names of my different trusses here. But basically equilateral triangles coming all the way up back here. And that should put my last node right here coming down right into this section right here, which is I think closer to some of the crane designs that I've seen. So I'm going to model that up and see how that looks. And on this design, I've got an idea of how many nodes I want coming across the bottom. That will then define how many nodes I want coming across the top. All right, so let me get started on this. I'm going to get rid of this screen for a little bit. As you can see, I'm going to have that just off to the side while I'm doing my designing. And let's see if I can do this without throwing everything off the screen. There we go. Okay, so I'm back into Fusion 360. And this time, rather than doing my design in AutoCAD, I am going to start out with a new design. So I'm just going to close this file right here. Sure, I'll save my changes. And let's go on here. I've got a new structure coming together. And this time I'm going to start out with a new sketch. Okay, and this is the same way that we started out with our design that came in from AutoCAD, except at this point, to bring it in from AutoCAD, I came along and I went Insert, and I brought it in from AutoCAD. Here I'm going to start out by drawing my major support nodes first. And so I'll come along here and I'll pick up circle, and it really doesn't matter where you put it on here. And I'm just going to create a 30 millimeter diameter node right there. And then I am going to create another 30 millimeter diameter node right here. Actually, before I do that, hold on. I'm going to create a line to connect these two because that is part of the process here. So I turn on construction line, okay? So on my sketch, there's going to be a construction line. I'm going to click on line, and from the center of that node, make sure you've got the center selected. I'm going to draw a line right in here, and I'm going to say right to there. And now I'm going to dimension that. So I click on sketch dimension right up here at the top. I click down here, and I'm going to make that 70 millimeters on the backside. Now I'm going to be able to come along and play with that dimension later. As you saw, this lets me play around with this a lot. I don't want this to be a construction line. I'll fix that in just a moment. But that is going to be 30 millimeters in diameter. If you come along and do something silly like that, just click on the line and turn off the construction line option. And now you'll see that becomes an enclosed shape. We could just go through and extrude those right now if we wanted to. Alrighty. And now what I'm going to do is I'm going to come in here and I'm going to draw some more construction lines and some more nodes along the bottom. I wanted, did I just turn that back into a, yes, I did turn that back into a construction line. Okay, I'm going to come along here, I'm going to create a line, and this time it's going to be a construction line. And I'm using the construction lines to space these things apart. And so I'm going to create that right there. And I'm going to create a node right there. And that node is going to be a 10 millimeter diameter node. That's just one of my little nodes right along there. I don't want that to be construction lines at all. So you're going to have to get used to switching in and out of construction line as you come along here. And I want a dimension. I don't want the dimension of the circle. Keeps wanting to dimension that circle. Hit escape a couple times. And I'm going to hit dimension right in here. And in my calculations, I said I wanted these to be 85 millimeters apart. Poof, that moves that 85 millimeters apart. Now, the other thing you'll notice that's happening as we come along here, I just hit escape to get out of that dimensioning mode, and you'll see that I've got these little markings here. These are called constraints, and you can see all the different constraints that we've got options along the top. So this one right here, slash slash right there, you can see that one says it's parallel. Okay, so those two lines are parallel to each other. In fact, they're actually collinear with each other. And this one right here indicates that this is going to be horizontal. And it's important to have those constraints in place. Where I tap right on here, you can see that I've got these constraints right on here, indicating that they're coincident. So the end of this and the center of the circle is locked together. Okay, that means that when it comes time for me to change dimensions later on, Fusion 360 knows how I want to move those. And if it's not moving properly, we can apply additional constraints. All right, construction line, another construction line right here. And as you can see, each of these construction lines is eventually going to represent the members that do it, but I'm doing this as construction line first, so I can program this in properly. And I'm leaving these individual. I could just come along and tell them to all have even spacing, but I'm going to want individual control of these later on to play around with this. And turn off the construction lines for my circle. There's another node, 10. And then I'm just going to carry this on until I get this line all done. So I'm just going to hit pause while I do that. Okay, and thanks to the many wonders of OBS Studio, I was able to pause that and then just pop along, and you can see that I've got this all done right in here. Each of my nodes is 10 millimeters diameter. Now you might want them to be a different diameter. There are ways that we can set this up, and you can actually have a little spreadsheet that controls the diameter of each one. Let's get this part figured out first in here. Now, it is a good idea when you come along here to come and test this to make sure this is all going to work. So if I come and double check on that and say I want that 80 millimeters long, that jumps out. Control Z, let me undo that. And if I double click out here and say that's 150, that shoots out there, and I can undo that. So these ones are all moving properly relative to each other. It's a good idea to test your constraints as you go along every now and then. Okay, you can also come along here and under inspect, you can do a measure. And so if I want to measure how far it is from that center right there to that center right there, it will come along and tell me that's 580 millimeters. 580? I thought that was supposed to be 590. Where did my math go? Oh, no, it was supposed to be 510. Okay, the X position right here, I was looking at the wrong number. It's this number right in here. If I'm looking for distance, I should really look under the thing that says distance. Okay, so there we go. I've got my 510 coming along right there, and that should give me a 600 millimeter long truss overall. Okay, now it's time to add some of the nodes right up here. And I think what I'm going to want to have is a tower come up right in here, and then a truss that comes back in this direction. So for my tower in here, I'm going to come in here and I'm going to turn on my construction line, and I'm going to hit a line right here, and I am going to bring this up right in here. Okay, and then, you know what? I'm actually going to bring that down there. I'm going to draw both of these at the same time. There we go. And what we're going to do is we are going to create a node right at this point right here, 10 millimeters in diameter. Now, the cool thing about this is, remember, like I said, I made a mistake. I didn't want that to be a construction line. I'm going to make that not a construction line. There we go. Now, if I come in and I dimension, I don't need to add a dimension to the circle. If I did add a dimension to the circle, because I just told it it was 10, I'd click on there and it would tell me that it's over constrained. If you apply two constraints to the same thing, so for instance, if I try to tell it that I want it to be 10 millimeters diameter, but 6 millimeters radius, that doesn't make sense, so it can't do it. And so Fusion 360 recognizes that, and when it says over constrained, it says I can't do that. I've got too many dimensions already. You can create a driven dimension, which means that this will always be subordinate to the other dimension, but then you can't come in and change the driven dimension to create a driving dimension. So I'm just going to cancel that right there. What I actually wanted to dimension was this line right here, and I've got that set at 120. You know what? That strikes me as a little bit high. I think I am going to come in here, and rather than that have that be all that tall, I'm just going to make that into a 70 millimeter high piece. And then from there, I am going to come along and create another piece that comes up here and create a node right up here. And that node will be, pick that. Sorry, I need to pick that. I need to turn off its construction. And now I can come along, and because I didn't put a dimension on that earlier, I can come in and dimension it and make it 10. Now I'm curious, I think I'm going to try running a string down here to start. I'm not sure if I can tie the string tight enough to make that happen, but I'm going to give it a try because I know that from here to here is totally going to be in tension. And if I can make that out of a string, it's a lot lighter than using wood for it. So we'll give it a try. I can simulate it. We'll see how it's going to happen. And then we'll see if I can go and tie it and actually get my string tight enough to make it work like the simulation works. Okay, now I'm going to come in here and I'm going to add some more pieces right up and down in here. Now, I've got a couple ways that I can go about doing this, and so I'm going to create some construction lines right here, and it's possible to find the midpoint. Now, if I come along right here and I get in here and I keep moving along, eventually, you see where that little diamond shape shows up right on there? That is going to create a midpoint link, and I'm going to come up vertical right from the midpoint right in here, and I'm not worried how high I come up. I'm going to come along. I'm going to come right to here. Okay. Now, if I want to find the shortest place where I can put a node right in there, and I have to be 70 millimeters away from here and 70 millimeters away from here, I'm going to draw a circle right on here, and I am going to set my diameter to 140 because that is a radius of 70. And then I am going to draw a circle right about here. And I'm going to set that diameter to 140. And where those two meet, that is the absolute lowest point where I can put an equilateral node right in there, okay, because they need to be 70 millimeters apart. And now I can come in here and I can create a circle right on there that is 10 millimeters in diameter. And now I can come out and I can take that circle and change that off right there. So now if I want to play around with this, I can actually come in here and I can change this one up to 150. Okay, and that moves along that circle right there because that linked to the intersection of that circle. Now, maybe that's not exactly where I want it linking to, but we can change that with our constraints so that I can take this dot right there and I can come in constraints and I can say I want that to be coincident right there with that line. Okay, and that one now, if I come in here, oh, no, it still wants to go that way. Can I make it, actually in this case, I can't make it both coincident to this line and to that line and to that line. I just have to set it to be that intersection. So I'll have to play around with that by playing around with these dimensions right in here, but that's got me aligned nicely right up and down in the middle, and I can use that as a reference point for other nodes along here. Now, what I'm going to do is I am going to come back and I'm going to create some lines right here. I guess another way that you could have done this is just to draw a line from right here down to right there, and a line from right there down to right there. And I could get rid of these circles now, actually. And I could take that line, and you see it's red because it's not dimensioned. And I can say I want that to be 70. I want that to be 70. That's probably just as easy a way to go about doing it. And so let's come in here. And now if I change this one here to 80, what happens right there? That tilts right along there. I guess it just gets rid of my construction line up there, which I didn't really need anyway. Different ways of playing around with it. I didn't have this sketched out properly beforehand, so that's why I'm playing with it a little bit now. All right, let's come along right in here, and more construction lines. It's going to come up right here. And I got a couple of options. One, I can tell it that I want it to come along at the same height as that one and come down right into there. And you'll see that this line has been marked. And if I mouse over it, you see how those two lines blink? They're marked as being parallel to each other. I can come along here and I can say, well, I want this line and that line to be parallel. Okay, and now if I come in here and change this dimension, those lines shift as well. So I can change all of my structure like that with one simple keystroke. So if I want to make everything go taller, I can change the length of those nodes. Pretty easy to do. And again, how you set your geometry up now affects how you're going to be able to easily edit it later on. Let's create a node right in here. Okay, and now I'm going to create a couple more lines, construction lines right in here, and I'm going to make them, there's that parallel. It automatically figures that one out. Okay, but I have, see that one remains red. That means it's lacking in constraints. So I can come in here and I can say I want parallel, this one, that one, and now they're all parallel along there. I make some changes down here. It changes everybody. I'm going to finish off that. I'm going to add a node right there and bring this all the way to the back. And you can do the same while I'm on pause. All right, so I came along, and as I was doing this, I came to an unexpected, if I take a look right here, this node is within 70 millimeters of that node right there. that is an illegal node. So I either have to move it up to there, okay, which could be done, or I have to say, well, I guess I'll just put one big, thick, heavy member coming right up in here and see how it does. Oh, I was really hoping to be able to put that in there to brace that. I guess my other option would be bring that out over onto this side, but then that means I have to bend that structure coming down right in there. And all of a sudden things start to get a little bit heavy. Well, that's something that I can play around with later on. What I'm going to do right now is I'm going to get rid of that big circle that I drew to illustrate the 140 millimeter problem. I'm going to get rid of this node right up here. That member right there. And I'm just going to change that up and make that 120 millimeters high. Okay, a little bit awkward, not exactly what I wanted, but there's my tower to come out and support my members all along right here. Okay, now that I've got these all drawn in, I am going to draw some construction lines to join them along the top. And you can see the truss is starting to form. Okay, did I make that tall enough to get away? Oh, better check. Yes, so that was far enough to get away from in there. Always check to make sure your truss nodes are at least 140 millimeters apart. Now you can come in here and you can test this, and if I say I want to change that up to 90, that changes all of the angles right in there and changes their heights. And if I want to change this line right here, it's a little awkward to see where that number is. Change that number up to 90. That increases all of their heights. On the other hand, that also puts me a little bit closer right in there. So right now, I'm going to try to keep this nice and lightweight. There might be some advantage from making it a little bit taller so that it doesn't have quite so much horizontal force that it's got to deal with. There might be some advantage to making this side a little bit shorter and this side a little bit longer so that the rotational moments aren't quite so big. All sorts of interesting design challenges that you can play with if you understand how this structure is behaving itself. Okay, so let's take a look at what we're going to do right now. So we've got our basic structure laid out, and when I change my key dimensions, everything seems to be working correctly. I can come in here and I can change that up to 120, and you can see that change. Now, why did that have to go up? That's because this line has to be parallel to this line, and that line has to be parallel to that line. So they kept that parallelness, but by changing the base, the only way that could change was that came up taller. Okay, there we go. So we've got the basics of our truss coming along right in here. Now what we're going to do is we're going to turn off our construction line, and we're going to come back in here and we're going to modify, and we're going to use the offset command. Okay, now right in here, I am going to come in and I am going to offset this one by 3.5 millimeters on one side, and you can see that it chained around here and it took this entire chunk because those two are joined right there. Turn off chain. Okay, and let's just cancel that. Let's go modify offset. Make sure you've got chain selection turned off, and I should be able to pick that one right there. And now it doesn't go around that corner. It's fine if that's what you want, but I may want to put different dimensions on here that I've got right there, and the chaining won't let me do that. Okay, and now I'm going to hit the O key. So as you can see right next to this, offset has the letter O. So hitting O is the same right there. And I want to move to this side. You see that's a negative dimension. So that is minus 3.5. And that offsets that line right in there. And I'm going to come in here, and this one's also going to be in compression quite a bit. So I am going to offset that by 3.5. The largest cross section I'm allowed is 7 millimeters. So minus 3, oh, not 0.35, minus 3.5 right in there. Okay, now this one should be in tension, And I do want to put a string up and down there, but maybe just to help me get that into tension, I'm going to put a little member right in there to deal with some of the tension. So O for offset, 1 millimeter on that side, and O for offset, minus 1 millimeter on that side. And when I do these things, you'll see that structures start to turn black and enclosed areas start to form up. These are the enclosed areas that I'm going to be able to extrude later on. Okay, so now you come in here and again, O for offset right there. And this one, I am only going to do this 2 millimeters. I don't know how strong it's going to need to be, but I know I can come back and change it later on. -2. Now along the bottom here, this is going to be in compression, and I think it's going to be in high compression. So I'm going to do my whole bottom to 3.5 and -3.5. O for offset. Okay, so now you can go through and do that for all the members of your truss, and I'll do that while I'm on. All right, so here we go. I've gone through and I've added my offsets all the way through right in here. So things are starting to look a little bit promising on here. And now it's as good a time as any to go and test and see if this is still working. And if I change that up to 150 millimeters, 150, that jumps up to 150. 120, it comes back down. If I change this one to, oh, that's one of my offsets. If I change this one to 120, all of a sudden I get that big lump right there as everything changes up. Okay. I'll have to watch it on here because I really can't change this to less than 85 because if I do that, these sides shrink, which brings me down to less than my 70 millimeter on these dimensions. So there could have been maybe a little better way to set that up and program that in there, but we'll see how it goes. Okay, and let's see. That's all looking pretty good. So I guess the next thing to do is to add the holes in the middle of the nodes right here. That gets pretty easy. We just come along and right here, I need to leave a 13 millimeter diameter hole. So 13 right there. And now you can see that separated out that middle. Okay, this one also needs, if I right click, I can just go repeat center diameter circle, or I can click on the circle button again, 13, and then I'll come up here. And for using the small bamboo skewers, I found that 3.4 millimeters seems to be about right. But after you've done some experimenting, you may say, Jason, that's not the perfect dimension. Okay, and that one's sitting right in there. And create another circle right there, 3.4. And as we create that circle, you see you get that concentric mark showing right on there, meaning that whenever we move the outside circle, the inside circle is going to change too. So I'm just going to go through and create a bunch of 3.4 millimeter diameter circles in the middle of each node so that when I finally extrude this, I've got my holes in there waiting for me. I've got a few nodes left to do, so I'll do that and I'll get back to you. Okay, so I've got all of my members set up with little holes at the nodes right on there. Later on, I'm going to add a string that comes up from right here and then comes out and joins right in here so that I can put the top all into tension. And so hopefully if that holds tight back there, that's going to be strong enough to keep this all from collapsing for me. And we'll have to see how that all balances out. Definitely looks a little bit like one of those big cranes, the tower coming up here. This will be our counterweight coming down. There's the tower of the crane coming up in here. This lever arm's really short here, which is probably going to cost me. That's going to make the total amount of force coming up in here pretty darn high. And so I might be wiser to shorten some of this down and make this a little bit longer, but we'll have to see. Simulation and testing will let me know how I am doing on here. Okay, so now that we've got this all put together, and I know that seems like a little bit more work than throwing it together in AutoCAD, but the ability to then go back and edit it just by changing the dimensions is probably going to make your life a little bit easier. And now we've got our diagram right into here. We can finish sketch and everything's sitting right in here. And this is sitting here, and we're going to do the exact same steps that we did for simulating this in my other video where we used an AutoCAD design. So I'm going to come in here and I'm going to tell it I want to extrude. And I just have to be careful about what I pick in here to make sure I choose all the parts of the structure and none of the parts that aren't part of the structure. Like watch out right here where these ones overlap because their lines cross. We want to make sure we include that. And we don't want to include this middle part. So if you click it, unclick it, don't let it stay blue. Okay, and you do kind of have to zoom in because there are little bits and pieces like that. That's good right up there. Actually, this part should be included because that goes into that member right there. That's looking pretty good. You do have to zoom in on these bits right in here to make sure you get everything that should be included. Like that part's part of the round node. That part's part of the round node. That's a member. That's a member. It's a member. Don't forget about that little bit at the bottom. Go zoom in, make sure you got everything. Doesn't matter what sequence you do them in, just so long as you remember. Oh, like look at that little sneaky bit missing right there. You do have to zoom in and pay attention to each node as you go past it. Because it doesn't know what you're trying to do. Like you've, drawn a shape and it's like, well, what do you want me to extrude? You've got to tell me, and you've put all these extra lines over top of me. And maybe sometime it'll get to a chat GPT like thing where it'll figure it all out for you. But my experiences with chat GPT so far have been entertaining, but I'm not about to start relying on it for anything too important just yet. Okay, I'm going to finish this off, and I think you've got the idea of picking out all those circles in the middle. And I've gone through and I've picked out all of my circles, and I am going to extrude this 3 mm because we're cutting it out of a 3 mm piece of MDF or hardboard, as the case may be. There we go, 3 mm. Now, I intentionally left an error in here, and if you look over it carefully, you can see right down in here, there's a little bit of an error. Oh, that one I left accidentally. Okay, and the other thing I left out was I wanted to put a 3 mm diameter hole right in here for tying my string to at the back. So I've got a few changes that I need to make to my sketch. This is a beautiful thing about Fusion 360 is we've got our history line down here. So if you've made a mistake, don't panic. Okay, I can come in here and if I double click on my extrude command, okay, there's my extrude command that says I've got 114 profiles selected. I can go through and I can either remove a profile, click it on again to add it back in, or I can come in here, I can add it back in, and I can watch that profile fill in nicely right there to make sure that I've got it right in real time. Oh, and look at that tiny little bit that I missed. That would have messed up my my simulations a little bit. Would have had a very hard time meshing that. And so I can say, okay, I like that. That looks a little bit better. And then I can come in. Oh, there's a tiny little bit missing in each of those, is it? Wow, look at that. That's just the angle I selected for right there. We'll select that. Looks like that's missing on each of those bottom ones. I think I fixed that one already. I swiped with the mouse and ended up selecting a whole bunch of things that I didn't want to select there. I was trying to pan. That one I got the first time out. Missed that one. And now we're back over there. That's fine. So, okay, I should have those all filled in now. And again, a little check to just carefully go over things. Now I'm using my fancy 3D mouse. You might have to use your view box to rotate it. There's also another way that you can rotate right down in here. But anyway, go ahead, take a look at it, and make sure that everything rotated. Now, I said I left something out right here. If you want to change something back here, come back here to your sketch, okay? And I wanted to have a little circle on here, so I'm just going to figure out how far out do I want it. I want it to come out, oh, let's say 23 millimeters. Actually, let me make that 20, 20 millimeters right there, maybe 22. I'm just sort of picking a distance. And then right on here, I'm going to create a little circle. This is not going to be a construction line circle. I'm going to create a 3 millimeter diameter circle right there, as the rules allow for me to have a place to tie a knot for that string that's going to come up around there. I hit finish sketch. Everything in there is still good, but now I want to edit the profiles that I've selected. So I double click right in there and I tell it, I don't want that part right in there to be part of my truss. There we go. So I got my little hole right in there. This is going to be my tower. String's going to come down right out here. I'll add that later in. Right now I'm just creating what I want to draw. And that's excellent. Now, how do I get that onto the laser later on? So what we do for that, and there's a real shortcut that you can do, is you can just go ahead and go create a sketch, click this plane right here. Now you've got a new sketch, project, make sure you get that whole red outline and go OK. And then you can come down here and finish sketch. Under your sketches, we just did sketch 2, and you can save that as a DXF, and that'll go onto your flash drive, and you'll be able to take that to AutoCAD and cut it on the laser. There are ways that you can cut from Fusion 360, but I've already got the cutting instructions laid out for how to cut from the laser. So that's how you get it off of there, is you just create a sketch, project your profile onto it, and then you go ahead and you cut that out. Okay, now that seems like more work than doing it in AutoCAD. Okay, but if I want to change something in here, now all I have to do is come back here, double click on my sketch, and well, I'm going to try this 140 millimeters tall to see how that works. And I'm going to increase this dimension to 75, and sorry, I should have hit return right there. And I'm going to increase this dimension to 75. And now I click Finish Sketch. And here's my truss all in those new dimensions, I don't have to go back and redraw my drawing. It's all there because I created it in a parametric format. All right, so I need to know some information off here. You could switch over to the other video right now because that's where I'm going to show you how to uh, uh, create, move and copy this, how to create the members that go across, how to apply some materials and get a mass. So I'm going to do that pretty quickly right on here. And you can see that in the other video where I imported direct from AutoCAD. And while I was doing that, I just discovered a little glitch right in here. Um, this little circle right in here was not concentric to that circle right there, so it did not move with it. So if you run into a glitch like that, again, it's the beauty of having everything parametric. This face was controlled by this sketch right here. So if I come back to this sketch right here and double click on that sketch 1, I come right in here and you can see this one did not move with that. For some reason when I drew it, it missed the concentric constraint. So if I go concentric and I say that circle is concentric with that circle, now that pops it in there, and anytime that one moves, that's got constraints on it. So it should be good to go. I'll finish that sketch. And now I've got a hole right there. And although I did some of my extrusion to get these to come across right here, I can now come in to finish off this extrude. And I can say, take that surface and extrude it there, extrude it there, and extrude it there. Okay, and now I've got that structure all put together in like so. That's what the main structure is going to look like. I can come along and I can apply some materials to it. So if I come in here to my bodies, body 1, physical material, and again, I explained this in more detail in the other video, but we'll pick up some MDF fiberboard, bring it up there, and we'll edit it. I always have this in the wrong place when I go to edit it. Edit it, you come to the advanced settings, you come in here and you go to physical, and for my mechanical properties, I've got this document right here where I talk about the mechanical properties of hardboard and MDF. The MDF settings that Fusion 360 has are okay. You can see that they have a lower elastic modulus. I've set it to 3.7 in here. Based on what I've seen, 3.7 seems about right for MDF, but they've set it a bit lower. They've also got the density down at 0.8. A standard one is 0.95. Our density, well, you'd have to measure it to know for sure. Our modulus of elasticity, you'd have to measure it to know for sure. But those values are okay for getting started. I might come back and do the analysis later on with the numbers that I've measured in the shop, but you can go measure your own numbers. The better your data from the shop, the better your results are going to be in the analysis. The more realistic all this work is going to be. I'm going to apply those settings, then I'm going to come into my appearance, and then just so that it doesn't look like regular MDF, I'm just going to change the color a little bit. In my other video, I made it green. Green was a bit of overkill, but I just wanted it to look a little bit different so that when I drag it on here, and I can see a color change. Okay, and now I know that's my custom hardboard material right in here. And now I can come in here and take a look at that and go, what are my properties? And that is telling me that my mass is going to be 68 grams. And that, if I can make it hold, is just about in keeping with a 4,000 score in here. So if I can put my, oh, I forgot to add one node right across here. That's going to have to run right across there. So maybe it's 68 and a bit. That's going to be close to a 4,000 score. And then if I can come back and lighten a few things up, maybe I'm going to start getting close to that 5,000 if it all works. Okay, well, let's see what happens. Okay, so I've gone through and I've extruded everything through right here. I've already done the copying, so I put a couple of steel supports in here, the front and rear support. I made sure their physical material was steel. I made sure that they were cylindrically jointed right here so that the entire frame could pivot and rotate around them. And then I created an offset plane, projected the nodes that I wanted to tie onto right here. For my design, I just tied it around this steel support at the back, but honestly, you could tie it right around there. Um, I guess one thing I didn't do in my original video, maybe I needed to include this as a rigid group in here or put a cylindrical joint between these two structures and this one right here. That might be a bit more useful, although it seems to figure that out in Fusion when we do the simulation. So let's see what else is going on around here. Everything's looking pretty good. I'm probably, oh yeah, I made a rigid group out of my lines coming right here. I'm ready to move to my simulation. Okay, I've got some results back. And just looking at this, I see a lot of red up here and a lot of warnings. I'm maybe not as concerned about them as I should be now. This is the this is the static stress analysis, not the structural buckling. And I think this part may be prone to some structural buckling, but you can see that what it's saying is that these wires are going to be pulling down so hard right in here that this is just going to bend down. Now keep in mind that we modeled this using our hardboard material coming across there, and that's not quite as stiff as the bamboo that we can put in there. And we can also increase the size of this node and put a 3/8 inch dowel right across there, which would really stiffen up that top. And I think that would help a lot because you can see if that's pulling down that hard that way and it's causing that to bend out already, this is just the static stress. It's not the structural buckling study. And that part worries me. And I knew going in that these long members up here were going to be bad news. But I was kind of constrained because of where that node is. I might have to change this up at the back so that this comes down right in here and I get rid of that node. Then I can put two nodes going up there to stiffen it up. We'll see what the structural buckling analysis says right on there when it's all done. But what the really good news is on here is what an impact having those super stiff tensile members has on the overall truss. Normally, a truss like this, if it was cantilevered out here and joined up right across here, the top would be loaded in tension and the bottom would be loaded in a whole bunch of compression. But because this is pulling right back in here, it's pulling that back into compression as well. So you can look and you can see a whole bunch of green right along here. It's not until we get right back to the back that we see it start to get into the yellow range. I can inspect and create a surface probe right here, and I can take a look. And even in there, I'm getting safety factors of 3, 4. It gets down to 1.2. So right on there on that side, that's getting a little bit compressed. But up here, safety factors of 14, 15, 3, 5, that's really sturdy and quite a bit overbuilt in some of these sections right out here. I should be able to come along and based on just the static stress, I should be able to reduce the size there, get that weight down, and maybe get the score up and have a chance of a design like this actually working. Okay, but let's see, the structural buckling just came in, and maybe that's going to put a damper on my enthusiasm because here is my structural buckling study. And if I come in here to my results, okay, well now buckling mode 1, keep in mind it's negative results. Okay, that's so if we're pushing up on it, everything's nice and stiff. We've got to come down here until we find the first positive result. These are all negatives. Now you'd think that they'd build an option in here saying, show me the first positive result, but they seem to really want you to take a look at, oh my God, look at that. The first positive result is 0.976 of the load. And that's buckling right up there. with a couple of tweaks, this design might actually work. I mean, I knew those were going to probably be the place to buckle, but look at how rigid everything is right in here. Looking right down there, I'm not getting any buckling right along here aside from what's caused by that popping out to the side and pulling in there. I think I've got room to make this work. Maybe remove a bit of material in here, add a bit of material in there, and I might be able to get something into the 4,000 range, maybe even into the fives. We'll have to see. Again, we have to verify it and we have to test with the actual material properties. The material properties I've given you are close, but you can get them closer still by taking some measurements in the shop. Well, there we go. If I want to change this now and try a different simulation, I just need to click on Finish Results, get out of the simulation, come back to my design tool. There's my hierarchy of how I built everything. I can come back into that original result and I can say, well, what happens? That all looks a little bit overbuilt. So I can come in and I can change these dimensions, make these all a little bit smaller. Um, I wouldn't make them too much smaller. In here, as you can see, I've got a problem that it could be stiffened up a little bit. I think I want this node up at the top to be a little bit larger. So I can come in here and I can say, well, what happens if I take this all the way up to my maximum 20 millimeter diameter? Okay, and what happens if I take the little bit right here in the middle and take that up to what's my maximum size? It's going to be a 3/8 inch dowel, and 3/8 inch is 9.5 millimeters. Okay, so I'll put my largest dowel in there. I'll finish that sketch. Okay, and because I designed this parametrically, notice that my knot has now expanded to accommodate the larger dowel. Okay, bigger chunk right up there. And maybe it's going to be a little bit more rigid if I space it across a little bit. Now, if I was building this by hand, I'd have to build two separate trusses and I'd be like, oh, that's going to be a lot of work. I can test this one, and while it's solving that problem, I can come back and I can say, well, let's see what this looks like if it's a little bit wider. But I'm not going to show you those results because this is a little bit of a competition. And I think I've tipped my hand a little bit already. Alrighty, folks, have a good time. Good luck with your designs. And I hope you know, if you don't have to use the parametric design, but I do want you to know about it because I think if you take the time to set it up initially and you've worked through a few different design ideas, it might give you a little bit of edge in developing your designs. It's one of the really cool tools that Fusion 360 has, and I use it in all sorts of applications for different things that I model in Fusion 360. I don't just use this for creating trusses, but it works pretty good. Oh, before I go, got to show you one more thing. Okay, because honestly, this is pretty cool. We did simulation. Let's go into render and bring this in right here. And you can put a background in here, but let's just go render. Oh, actually, sorry, I don't want to do a cloud render. You can do an in-canvas render and just hit in-canvas render. And so if you want a nice picture of your truss, yeah, okay, we could have chosen a nicer color for our MDF right in here, but this has the ability to come in and generate some pretty cool photorealistic renderings sitting right in here. So that's one way to get a very cool looking truss, and it will keep refining that and refining that, and the quality of the image will get better. You can put backgrounds in here if you want in canvas render settings, fast, advanced. I'm just gonna stop that for a moment. Let's see, in canvas render settings. I guess that's if you're going to do the online render, there's all sorts of ways you can set it up with a background. Oh, scene settings, here we go. Environment library. So you can say, I am going to put this into a field. Download the environment. You drop it in here somewhere. There we go. I think we're out in the field now. Set the background to the environment. There we go. Now you can render your truss in a field. You could bring in your own photograph to make that into the background. Um, okay, that's really cool. You can do all that. So that's render. You can create a drawing of your truss, and you say from the design and full assembly, create new. What size paper do you want it on? All of those options that you can pull out. And it's going to come in here. Give it a second. There we go. Place your base view right here. Now let's change that scale around. Let's make it 1:5 scale. Does that show up a little bit better? Let's make it half scale. Place your base view right there. Oh. We'll say OK. And there's a design, the side of your truss. And then if you want a projected view, parent view, there's your top view right up there. So you can see everything on the truss coming through right there. Maybe in this view, just a minute, you want to, let's see, you've got some options on here. Sketches, truss, rear support. Wasn't planning to have this part of the demo, but I was just having fun at the end. And projected view, parent view. Press that right over there. Okay, there we go. Yeah, so you can create nice line drawings of your orthographics in here. Put them in there somewhere. Yeah, no, I kind of ran out of space. Maybe 1/2 scale is a little bit big, even for a big sheet of paper like that. But anyway, you can create some very nice line drawings of your drawing in the drawing mode. Okay, and you can export it as a PDF when you're ready to do that. So I'm just going to close that. I'm not going to save that. So that's design that we've used, render, simulation, and drawing modes are all very useful in here. Generative design is really cool. It's kind of like finite element analysis, but in reverse, you set up a set of parameters and say, find me the most efficient option. I've got enough weird parameters in our challenge that it's really hard to set that up, so it's not that helpful. Animation lets you create animations showing how things come apart and together. And manufacturing, that's where if you're doing, actually I think James is going to use this a little bit with you in your CAD/CAM CNC course, and it generates toolpaths for you, which is really cool as well. So a ton of stuff packed into Fusion 360, and we haven't even started talking about how it does electronics yet. Oh, just wait for that. I'll be back.